So members, let us see more examples as we explore more tricks. So here is the example. We have the mean score of a random sample of 60 subjects was found to be 145. So mean that our n, here they are giving us our n as 60 subjects. Their x bar, the sample mean of those things, was 145. Was found to be this with standard deviation of, now our standard deviation is big. In most cases, when you find when they are, instead of sigma, they are using S, this means that the bias is unbiased estimator. Is when the standard deviation is too big, you use S. So when you find this means that the standard deviation is too big. So when you find this, don't fear it. Anyway, let me take it to the sigma people know. Construct a 90% confidence interval of the true mean. So now we have a 95% confidence interval. This will be the same as 0.95. And say after that, you get this to 2p. So our 2p is 0.95. So our p here, and divide that with a 2. We get 0.475. So now our z of the alpha over 2 will be, now we read that from the table. I think people are okay with reading the table, is 1.96. 1.96. This is 1.96 as you can see from the table. 1.47, I think you can see it. 1.475, 475, you see it's there. It's 1.9, then under a 6. Okay, then after that, they want us to get the confidence P. So this will be now x bar. We said it's the same as plus or minus z alpha over 2 sigma over root n. Then just substitute our x bar from here is 145 plus or minus. This one is 1.96. Then times our standard deviation, which is big, so 40 all over. Now root of n. Our n was 60, and this will give us plus or minus. When you press that on the calculator, we are having, you first press root 60, you press equals, then you say 40, divide by answer, you press equals, then times 1.96. And this here, we give it to 4 decimal places. 1, 2, 1, 4, 4 decimal places. So now, if they want us to get the limit, countries, constant confidence interval of the mean. So the confidence interval, we need our upper limit, which will be 145 plus 1214, which is going to give us, when you add this, you get 155.1214. Then our lower limit, we get this 145, then minus 10.1214, and the answer we get there is 134.8786. So now our interval is, you give it in in square brackets. The lower limit 86. We have seen how to comment. So I'm not going to repeat that. 1, 2, 1, 4. So that is our interval. Then they are saying here, assuming that the sample size is large enough for a normal approximation, what size of a sample is required to estimate the mean within 5 of the mean, with 90% confidence. In simple terms, this in our part B. Okay, let me do it here. In our part B, this is our part A. This was part A. Then in part B, That means that when you get x bar minus the mean of the population, it should be within 5. This should be less than 5. Now, this 5 is what we call the margin of error, which is n. And this n is given by this. This is what we call the sample mean. This is what we call the confidence multiplier. This one is called the standard error or the standard deviation of the sample mean. And all of this is what we call the margin of error. So now the margin of error they are giving us here is n. So from there, our n is 5. So the margin of error, and we have seen that there our margin of error is always z alpha over 2, then sigma over root of n. So now they are giving us this, they want this. So we can make this the subject. How do you make this the subject? We are going to get, so to make this the subject, so that our n from here, if we cross multiply, we have root n equaling to z alpha over 2 times sigma over m. So that when I get n will be equaling to, I square both sides, z alpha over 2 times sigma over m. They're all squared. So already, so whenever they talk about the margin of error, if they say something within, this is how you get the margin of error. The standard error is different. The standard error is just this. Okay, so from here, our n now will be substitute. Now it's the same confidence, 95, but we have counted already that. If they say 96 or 99, then you calculate again with this. But good enough, they use the same. So RZ alpha over 2 is 1.96 times our 40, the whole over 5, then after we square. So our n there will be, when you put that on the calculator, 96 times 8, square that. Here I'm getting 24, and then we approximate this to the next integer. So which will be approximately, the next integer is 246. So that's the size of n that should be used if we had approximate this to a normal. I mean approximation. So that's what we use members, that's how we get the interval and so on. So let us see my examples. The next lesson wish you well. Members, before we leave this lesson, I want to comment on the effect of the value of the standard deviation and then what's its effect on the interval. Now, the bigger the standard deviation, the value of the standard deviation, the bigger the interval. The smaller the standard deviation, the smaller the interval. That's why you see here the standard deviation is too big. That's why it's that even our interval is going to be big. But when the standard deviation is small, the interval is small. What do I mean by big? If it's big, it can be from 10, say mu, to maybe 50. When the standard deviation is big, say like 40 or 50. But when the standard deviation says it's big, that's when you find that the limit or the interval is going to be from maybe 10 mu less 13. This is what I'm talking about. So when this is big, this is going to be also big. When this is small, even the interval is going to be small. So take that difference. See you in the next lesson.